Alright, so this video is going to be on the layouts Codelab for Compose. So to find this Codelab, I'll put a link in the description and you can get it from there. Alright, so here we go. Layouts in Jetpack Compose. Alright, introduction. And the previous video was the Compose Basics. So this is the next one. Okay, in the Jetpack Compose Basics Codelab, you learned how to build simple UIs with Compose using composables like text, as well as flexible layout composables such as column, row, and row that allow you to place items vertically and horizontally, respectively, on the screen and configuring the alignment of the elements within it. On the other hand, if you don't want items to be displayed vertically or horizontally, Box allows you to have items behind and or in front of others. You can use these standard layout components to build UIs like this one. Here's one of Alfred Sisley. Alright. Here's a composable function, photographer profile. Takes a photographer object. It's a row. Inside the row there's an image, and then a column and two texts in the column. The name, and then last seen online, and ellipsis. Okay. Thanks to Compose's reusability and composability, you can build your own composables by combining the different parts needed at the correct level of abstraction together in a new composable function. In this Codelab, you'll learn how to use Compose's highest level of UI abstraction, material design, as well as low-level composables like layout that allows you to measure and place elements on the screen. If you want to create a material design-based UI, Compose has built-in material components, composables that you can use, as we'll see in the Codelab. If you don't want to use material design or want to build something that is not in the material design specs, you'll also learn about how to create custom layouts. Okay, what you'll learn. In this Codelab, you'll learn how to use material components, composables, what modifiers are and how you can use them in layouts, how to create your custom layout, when you might need intrinsics, prereqs, Kotlin, I got that, lambdas, got that, and then knowing the basics of Compose. We did that in the previous video. Cool. Next, starting a new Compose project. Open Android Studio and select a new Android Studio project. Here we go. I'm starting Android Studio. Let that fire up. Alright, new project. And it's going to be an empty compose. Let me move this over here. Empty compose. Right? Yep. Next. Alright, what's the name? Does it say the name? Your application name? It doesn't say what name to specify. Okay. Alright, click next. Configure project as usual. Make minimum SDK at least 21. Okay, we're good there. When choosing empty compose activity template, the following code is okay. Let's do this. Will be compose layouts. That's the project name. Finish. Okay. Alright, the following code is generated for you. Project is already configured to use Compose. Manifest the Gradle files. Gets those dependencies we need. With the build features, Compose true flag. Also make sure Kotlin compiler version is not present in the Compose options. let's double check that. We'll wait till it finishes loading. All right, looks like it's almost done. All right, it's done. Go to Gradle. It says this is in Compose Options. It says remove Kotlin compiler version from here. I wonder why. If we remove it, okay. Let me sync again, make sure everything still works. Build features, compose true, looks good. JVM target 1.8, user IR is true. I don't know what that means. All right. All right, looks like we have all the compose stuff. Compose, cool. All right, there's a solution. Let's keep going. Modifiers. Modifiers allow you to decorate a composable. You can change its behavior, appearance, add information like accessibility labels, process user input, or even add high-level interactions like making something clickable, scrollable, draggable, or zoomable. Modifiers are regular Kotlin objects. You can assign them to variables and reuse them. You can also chain several modifiers one after the other to compose them. Let's implement the profile layout seen in the introduction section. All right, open main activity. Okay. Let me make a little more space. Okay. And add the following. Add the following code. Okay, so photographer card. We gotta add that. All right, it's a column. And inside there we have text. And it's Alfred. We gotta import this. Alfred Sisley. All right, font weight. We gotta add some weight to the font, make it bold. Okay. Next, let's see, what is this? Composition local provider. Did I spell this wrong? Composition. Yeah, I did. Composition local provider. Local content alpha provides what does it say? Content alpha.medium. I don't know what this is. Let's see. I'll figure out what that error is in a moment. 3 minutes ago. What else? Style. Material. Theme. Typography. Body 2. Why can it not find that? What's in the content? Oh, it's lowercase m. Oh, that's why. All right. We're good there. Now we got to add this little preview. New composable. Oh, we got to annotate with preview. Function photographer card preview. Okay, layouts, Codelab. Oh, that's not what I called it. What did I call this? Compose Layouts. Compose Layouts theme. So we got to remember, they called it Layouts Codelab. We're calling it Compose Layouts. Photographer card. All right. With this preview, let me get rid of these two, the old ones. And then I'm going to add photographer card. Okay. Let's see the preview. Oh, I forgot. I have another JDK. Let me specify the right one. You probably won't have this issue. Alright, embedded. Apply. Okay. Alright, now let's see what it does. Build. That's kind of a disadvantage of Compose, is the build in between each change to the UI. You know, with XML, you wanted a preview, you saw it instantly. You don't have to rebuild the whole project each time. But who knows, maybe they'll be able to improve that over time. Alright, gotta zoom in. I think that's what mine looks like. The reason it kind of looks... yeah, maybe it's because my Android Studio theme is dark and theirs is not. I don't know. Alright, the app theme used inside set content depends on how your project is named. This Codelab assumes that the project is called Layouts Codelab. If you copy paste code from the Codelab, don't forget to update Layouts Codelab theme with the name of your theme available in UI/theme Kotlin file. Alright, now in this code snippet we're using composition local provider. It also allows us to pass data implicitly through the composition tree. In this case, we're accessing content alpha medium, the medium opacity level, which is defined at the theme level in this case by material theme. Okay, I was not okay. So that's just alpha. Local content alpha is just alpha, if you remember from XML. Provides medium alpha. I'm guessing that's like 50%. Does it say what the value is? Okay, 0.74. Alright. Okay. Alright, next, while the picture is loading, you might want to show a placeholder for that. You can use a surface where we specify a circle shape and the placeholder color. To specify how big it should be, we can use the size modifier. Okay. Alright, let's alright, where's our photographer card? Right here. We gotta wrap everything in a row. Alright, and then we need a surface. And what do we pass our surface? It needs a modifier. Modifier.size. And it's 50 dp. We need some more. What else? Okay, we need shape. And it's a circle shape. Okay. So it looks like there's like a lot of things pre-built that you're just gonna have to kind of learn, like you did with XML, like circle shape, or local content alpha. Colors on surface, copy, and then alpha. What is it? Alpha equals 0.2 float. Okay. The image goes here. Let's do a little build and refresh. All right, let's keep going. All right, that looks good. Needs some padding, but looks better. Okay, there are a couple improvements we would like to do here. One, we want some separation between the placeholder and the text. We would like the text to be centered vertically. Okay, for number one, we can use modifier padding on the column that contains the text to add some space at the start of the composable to separate the image and the text. For number two, some layouts offer modifiers that are only applicable to them and their layout characteristics. For example, composables in a row can access certain modifiers from the row scope receiver of rows content. That makes sense there. That make sense there such as that makes sense there such as weight or align. This scoping offers type safety, so you cannot accidentally use a modifier which does not make sense in another layout. For example, weight does not make sense in a box, so this will be prevented as a compile time error. Note, modifiers can play a similar role to XML attributes in the view system, but the type safety of scope-specific modifiers helps you discover and understand what is available and applicable to a certain layout. Compare this with XML layouts where it was not always clear if a layout attribute was applicable to a given view. Okay. Yeah, I can see that. All right. All right, so let's update the column with some stuff. So we got, let's go modifier. Padding. We're gonna add some padding just to the start. 8 dp. And then dot alignment. Oh, yeah, alignment dot center vertically. Okay. Do a little source format on that. Let's rebuild. And we should see a little padding right here between the circle. There it is. Awesome. Okay, most composables accept an optional modifier parameter to make them more flexible, enabling the caller to modify them. If you're creating your own composables, consider having a modifier as a parameter. Default it to modifier, i.e. empty modifier that doesn't do anything, and apply it to the root composable of your function. In this case, so we want to, on the photographer card, okay, so we'll have a modifier by default equal, and we set it to modifier, an empty modifier, I see. And then row is going to get that modifier. I see. And then, I see, okay. Note, by convention, the modifier is specified as the first optional parameter of a function. This enables you to specify a modifier on a composable without having to name all parameters. Order of modifiers matter. In the code, notice you can chain multiple modifiers one after the other by using the factory extension functions. Modifier.padding.align, I saw that, all right. Be mindful when chaining modifiers as the order matters. I did not know that. As they're concatenated into a single argument, the order affects the final result. Interesting. I could see that being a tricky source for bugs. Okay. If you wanted to make the photographer profile both clickable and have some padding, you could do something like this. Okay. So we're doing it on the row. Okay, dot padding 16.dp, and then what's the other one? Clickable. Okay. We're ignoring the click, but it's using interactive oh, we can interact, we can simulate that click over here, huh? Cool. Let's see. It doesn't seem very interactive. Oh well, I'll take the word for it. Alright. Notice how the whole area is not clickable. Okay, we gotta run it. We gotta verify this. Make sure it actually is before clickable. Oh, okay. Alright, let's see this. Yep, I see that. Not the whole thing. Interesting. This is because padding was applied before the clickable modifier. If we apply padding modifier after clickable one, after the clickable one, then the padding is included in the clickable area. Interesting. That is interesting. So we gotta change that. Oops, I might have screwed that up. There we go. Now let's run it. Note the explicit order helps you to reason about how different modifiers will interact. Compare this to the view system where you had to learn the box model. The margins applied outside the element but padding inside. Okay. Margins applied outside the element but padding inside it, and a background element would be sized accordingly. The modifier design makes this behavior explicit and predictable and gives you more control to achieve the exact behavior you want. Let's see. Okay, that's looking better. Let me get rid of this emulator. Modifier composable in a very flexible way. For example, if you wanted to add some outer spacing, change the background color of the composable, and round the corners of the row, you could use the following code. Alright, let's do that. Alright, row, what do we have? First is well, see here in this example, they put clickable after padding. Oh, they put, oh, they put two paddings on there? I don't know. Oh, I see. I think they want to have like a certain section of it clickable, but not. others of the row. I'm not sure. All right, let's play around here. We'll add more padding, 8 dp, and then clip. What shape? Rounded corner shape. Radius is 4 dp. And background is going to be material theme dot colors dot surface, and then clickable is right there, and then padding again. We'll do a refresh. It says using interactive preview. How do you make your preview interactive? I don't know. I'm just gonna run it. How modifiers work under the hood later in the Codelab. All right, moving to the next one. Slot APIs. Very nice, very nice. I think that 8 padding gave it that little, you see that little space around the top and side? I think that's what the 8 did. Okay. Compose provides high-level material used to build your UI. As they're building blocks for creating UI, you still need to oh, this restart. Let me start the camera again. I don't know why. For some reason, when I start the emulator, it kills it sometimes. I think the computer just can't handle it. Alright. As they're building blocks for creating UI, you still need to provide information of what you want to show on the screen. Slot APIs are a pattern Compose introduces to bring a layer of customization on top of composables. In this use case, the available material composables. Note, this section of the Codelab is theoretical. You shouldn't copy the code in here to Android Studio. Let's see this with an example. If you think about a material button, there is a set guideline on how a button should look and what it should contain, which we could translate to a simple API to use. Button, okay, that's straightforward. However, often you want to customize components well beyond what we may expect. We can try and add a parameter for each individual element you could customize, but that quickly gets out of hand. Very true. Therefore, instead of adding multiple parameters to customize a component in a way we cannot expect, we added slots. Slots leave an empty space for the UI for the developer to fill as they wish. Cool. For example, in the case of button, we can leave the inside of the button to be filled by you. You may wish to insert a row with an icon and a text. Awesome. To enable this, we provided an API for button that takes a children composable lambda. This allows you to define your own composable to be emitted within the button. Okay. Notice that this lambda, which we've named content, is the last parameter. This allows us to use the trailing lambda syntax to insert content into the button in a structured way. That is worth learning about if anyone's following along, learning about that. That was a surprise to me the first time I saw it. It's a little confusing, but quite useful. Compose uses slots heavily in more complex components such as top app bar. All right, makes sense. Here we can customize more things apart from the title. Example of usage: top bar, title, text, text equals page title, max lines 2, navigation icon. All right. When building your own composables, you can use the slots API pattern to make them more reusable. In the next section, we'll see the different material components, composables, available and how to use them when building an app. Alright. Material components. Compose comes with built-in material component composables that you can use to create your app. The most high-level composable is Scaffold. Scaffold allows you to implement a UI with basic material design layout structure. It provides slots for the most common top-level material components such as top app bar, bottom app bar, fab, and drawer. With Scaffold, you make sure these components will be positioned and work together correctly. Based on the generated Android Studio template, we're going to modify the sample code to use Scaffold. Open main activity and feel free to remove the greeting and greeting preview composables as they won't be used. I already did that. Create a new composable called Layouts Codelab that will be modifying throughout the code. Okay. New composable called Layouts Codelab. Alright, I'm going to put it right here at the top. At composable. And it's a text. Hi there. And then we're going to use that in set content, it says, inside of our theme. Alright, and in the preview, we're going to use that as well instead. Okay. If you see the compose, I'm going to refresh. If you see the compose preview function that must be annotated with @preview, you'll see Layouts Codelab as this. Hi there. Yep, I see it. Let's add the scaffold composable to our example so that we can have a typical material design structure. All parameters in the scaffold API are optional except the body content that is of type composable inner padding. It's a composable function. The lambda receives a padding as a parameter. That's the padding that should be applied to the content root composable to constrain the items appropriately on the screen. To start simple, let's add scaffold without any other material component. Okay. Layouts Codelab. Scaffold. Inner padding. And this is the text that's going to go in there. And we got to add a modifier on the text. Okay. And we add, oops. We pass it that inner padding. Why? Alright, what am I doing wrong here? Why can it not find modifier anymore? Maybe it's an import. Let me get rid of modifier and re-import it. Oh, I spelled it wrong. Okay. Alright, do a little build refresh with preview. It should look like that. If we want to have a column with the main content of our screen. Oh, okay, look at that. We should apply the modifier to the column. Okay, so we're going to add a column now. Alright. And it's got a modifier. And it's that modifier. Inner padding. is what's passed to it. Okay, and we can get rid of this. And we'll add a new text. It says, thanks for going through the layouts Codelab. Okay. Let me build and refresh with the preview. That looks like the preview. Okay. Let me get rid of that. Zoom out. Alright. Excellent. To make our code more reusable and testable, we should structure it into small chunks. For that, let's create another composable function with the content of our screen. Plot body content. Okay. I'm gonna delete this one. Actually, no. Just in case they decide in the Codelab that we should have that again. Function body content. And it's modifier. It takes a modifier as a parameter equals modifier. It has a column. Modifier equals that modifier passed in. And then we have those two texts. We'll get those over here, pass that in, and we'll call our body content. We got to pass in modifier, oops, padding, and inner padding. Let's refresh. It's typical to see a top app bar in Android apps with information about the current screen, navigation, and actions. Let's add that to our example now. Alright, top app bar. Scaffold has a slot for a top app bar with the top bar parameter of type composable function, lambda function, meaning we can fill the slot with any composable we want. For example, if we just want it to contain an H3 style text, we could use text in the provided slot as follows. Alright. Oh, interesting. Okay, that's pretty cool. It's right here, right? Yep, top bar equals lambda and then text equals layouts Codelab style equals material theme dot typography dot h3. All right. Very nice, very nice. Okay, with the preview, can I rebuild it? It didn't do it. Do I actually have to manually do this? How do I turn that off? Okay. All right, I'm gonna rebuild it since the button is not there. Okay. However, as for most material components, Compose comes with a top app bar composable. Wait, did I just? Okay. That has slots for title, navigation, icon, and actions. Also, it comes with some default that adjust to what material specs recommend, such as the color to use on each component. Okay. Follow the slots API pattern. We want the title slot of app bar to contain a text with the title of the screen. Oh, I see. Okay, so that's top bar equals that lambda function, and it has top app bar. Okay, and that has, oops, title equals another function. Okay, and what is it? That's where this is gonna go. What is going on here? See, title. Alright, let me step through this again. Scaffold looks good. Top app bar equals lambda function looks good. And you put inside there top app bar. And then we got title equals. And then that's also a lambda function. Title equals, oh, I see. This should be text. Okay. Alright. Let's get rid of some of this. I think this can be gone. There we go. Alright. We'll build and refresh. With the preview, alright, let's see if it looks like that in the preview. Cool. Looks exactly like it. Awesome. Top app bars usually have some action items. In our example, we're going to add a favorite button you can tap when you think you learned something. Compose also comes with some predefined material icons you can use. For example, to close, favorite, and menu icons. The slot for action items in the top app bar is the actions parameter that internally uses a row, so multiple actions will be placed horizontally. In order to use one of the predefined icons, we can use the icon button composable with an icon inside of it. Okay, so let's see, we have title right there. Next is actions. So after title, we got actions. Actions. We're going to use icon button. What does it take? On click, we'll leave it there. And inside that, we have icon, icons.fill.favorite, content description. I like how they do what they do with the content description, how they set that up. Okay. Everyone always kind of neglected content description. Alright, there's our little favorites icon. Cool. Alright, with preview, that's exactly what it looks like. Normally actions modify the state of your application somehow. For more information about state, you can learn the basics of state management in the Basics Compose Codelab. Alright, we did that in the previous video. Placing modifiers. Whenever we create new composables, having a modifier parameter that defaults to modifier. Having a modifier parameter that defaults to modifier is a good practice to make composable more reusable. Our body content composable already takes a modifier as a parameter. If we wanted to add some more extra padding to body content, we should place the padding. Where should we place the padding modifier? We have two possibilities. Apply the modifier to the only direct child inside composable so that all calls to body content apply the extra padding. Okay, let's do that. Body content, where's that at? Right here. It's on this modifier. Add a little padding, 8 dp. Okay. Apply the modifier when calling the composable that will add the extra padding just when needed. Oh, these are the two options. I see. Deciding where to do it totally depends on the type of composable and the use case. If the modifier is intrinsic to the composable, place it inside. If not, outside. In our case, we'd go for option 2, as padding is something we might not always force whenever we call body content. Oh, I see. So, okay, basically if it's optional, put it inside. All right. So we want to do it the other way, not on this column. Okay, so where we call here. Interesting. That is gosh, it's kind of confusing, but it looks like you see the modifier is padding, then it's called with it's past inner padding, and then padding's called again, and I think one of them will apply like outside of it, the other inside. It's kind of confusing, but can we preview it? Let's do a little preview, see what that did. Yeah, see it added 8, looks like it's 8 dp, and then that default. All right, let me delete it just to see the difference. So I deleted it, and then the inner padding is going to be coming from the scaffold. Yeah, I see. Okay. Okay. It's still a little confusing. Does that mean inner padding is 0? Because I didn't see any padding on the first one. All right, anyways, okay, deciding, okay, modifiers can be chained by calling each successive modifier function on the previous one. When there's no available chaining method, you can use then. In our example, we start the modifier, lowercase, meaning the chain builds on top of the chain passed in as a parameter. Okay. More icons. Apart from the icons we listed before, you can use the full list of material icons by adding a new dependency to the project. In case you want to experiment with those icons, open the Gradle file and import this dependency. Okay. Go ahead and feel free to change. All right, let's add the dependency first. Change the icons of the top app bar as much as you like. Further work, scaffold and top app bar are just some composables that can be used to have material looking application. The same can be done for material components such as bottom navigation or bottom drawer. As an exercise, we invite you to try to fill the scaffold slots with those APIs in the same way we've done until now. Okay, so with bottom navigation or bottom drawer. So let's see. I'm holding command and hovering over this. And I think we do, let's see, bottom navigation. Let's do, so I think, all right, there's top bar. Let's add bottom bar. And is there a bottom navigation? Here we go. And what goes in here? Modifier, background color, elevation, content. I don't really know how to use this, so let's see. I'm just gonna hit enter. I don't know what to put in there. All right. I don't really know what to put in there. We got about them, but let's see. Let me build and refresh, see what that looks like. All right. How much time do we have left? 51 minutes remaining. Jeez. Okay. Displaying a list of items is a common pattern in applications. Jetpack Compose makes this pattern easy to implement with the column and row composables, but it also offers lazy lists that only compose and lays out the currently visible items. Let's practice by creating a vertical list with 100 items using column composable. Oh, so there's our bottom navigation. How do we add? Let's see. Let's see what we can add here. I'm stepping into this. Content. It must be content. All right, we passed the content. How does content is a? Oh, I see. So I think. I am not really sure. We do icon, button. All right, let's see if that adds. Oh, there we go. That's how you add items. Oh, interesting. Interesting. Awesome. Can we just keep adding them? Is there a different one besides favorite? Let's see. No. No, there is not. What was one? This is use semicolon in Kotlin. I don't know about that. Oh, I see. So we just keep adding them. All right. Okay. We can add a modifier. What? Arrangement. We do, I don't know, like fill max width. And what can we pass here? I don't know, something like that. I'm just wondering if there's something like where you arrange them or align them in some specific way. Alright, I don't know. Figure it out later. Okay, lists. Okay, displaying a list of items is common. Okay, I read that already. Let's practice by creating a vertical list with 100 items using that. Alright. Let's make a new composable function. Oops. And it's a column. Repeat 100. Alright, and then text, item, number, and then it. Okay. Alright, and then as a column doesn't handle scrolling by default, some items aren't visible as they're outside of the screen. Add the vertical scroll modifier to enable scrolling within the column. Okay. Scroll state equals remember scroll state. Okay. And we have to add that to the column modifier. If I could spell. Vertical scroll, and we pass the scroll state. Alright. Lazy list. The column renders all the list items, even the ones not visible on the screen, which is a performance issue. Yep. That's like list view. When the size gets bigger. To avoid this problem, you use a lazy column, which renders only visible items on screen, allowing performance gains and doesn't need the scroll modifier. Wonder why they don't just always use lazy column. Like, why even have list view? Why not just always use recycler view? Or in this case, lazy column. Because I mean, on list view, you still have to get an adapter. It's not like you have to write less code with a list view. There's really no advantage to it. At least not that I can think of. Not a big enough one where it would matter. Lazy column has a DSL to describe its list content. You will use items which can take a number as list size. It also supports arrays and lists. Read more about right there. Alright, so change this to a lazy list or a lazy column. And make this a lazy list. And we don't need the scroll, or do we? It said we didn't need the scroll. Maybe we do. Okay, we have to do this. Oh, we don't do it with a modifier, I see. We say the state equals scroll state. All right. Displaying images. As we've seen earlier with the photographer card, image is a composable that you can use it to display a bitmap or a vector image. If the image is fetched remotely, the process involves more steps as your app needs to download the asset, decode it to a bitmap, and finally render it with an image. To simplify those steps, you will use the coil library, which provides composables that run these tasks efficiently. While we use coil in the code sample, you can choose glide or in a companionist wrapper if you prefer. I've only used glide. Let's try coil. Wait, what is this error? Found required lazy list state. Oh, did we do this wrong? Oh, remember lazy list state. I see. Okay. All right, let's go get coil for some image loading. Awesome. As we will be fetching a remote image, add the internet permission. Okay. Let's go to manifest, add that. Okay. Now create an item composable where you will display an image with the item index next to it. Okay. Make a new composable. A vertical. Come on, align? Nope, gosh. Some of the autocomplete in Compose really sucks. I wish it, okay. Oh, I'm typing the wrong one. Index, it's an int. Okay. Then we got a row. This takes vertical alignment. See, like, why would it do that one first? I wish it would do this. Okay. Alignment, center vertically. Alright, let's open this up. Image. Add. Oh, man. Okay. Painter. Remember. Image painter. The request. Let's see. Remember image painter. And it doesn't take painter. It takes. Oh wait, yeah, it does. It takes request, not data. Okay, I'm gonna copy this URL out. I don't feel like typing that. Okay. Painter equals, okay. Add content description, Android logo, modifier, $50 DP. I wonder how Compose handles different like sizes and densities. I wonder if that's somehow automatically worked out. Alright, image is good now. Now we had a spacer. Modifier width 10 dp. Text style material theme dot typography dot which one? Subtitle. I don't know, subtitle 1 we'll go with, I guess. Alright, that's all within our row. There's our image. Okay. Subtitle 1. Alright, good. Next, swap the text composable in your list with image list item. Okay. List scrolling. I'm gonna run this. Buttons that allow us to smoothly scroll to the top and bottom of the list. To avoid blocking list rendering while we scroll, the scrolling APIs are suspend functions. Therefore, we'll need to call them in a coroutine. To do this, we can create a coroutine scope using the remember coroutine scope function to create coroutines from the button event handlers. The coroutine scope will follow the lifecycle of the call site. For more information about composable lifecycles, coroutines, and side effects, check out this guide. Okay. Let's see how this goes. Oh, we forgot to show it. Let's see. This should be lazy list. Alright, let me run it again. I don't see it loading the image. That's weird. Did I put it in the right spot? Uses permission. Do I have internet? Yeah. Yeah, there you go. It loads fine. I don't know why it's not loading. Data. Did I put the right thing in there? Remember, on execute, builder, returns an image painter. Did I do this? Maybe I did it wrong. No, data. Huh. I am not sure why it's not showing up. Oh well. It might just be an emulator thing. Alright. Alright, let's see. Go back to our list. Where's our lazy list? Right here. Remember lazy. Okay, we have to make the size. How big? 100. And then coroutine scope after that. Okay. Finally, we had our buttons that will control the scroll. The scroll. Okay. I'm just gonna copy. Oh wait, these are both here. I'm gonna copy these over. And these go where? I think just right here. Add the launch. I did not know. Okay, let's see. Scrolling list. Did I? Image list item. I want to see that image list item. Yeah, I have it all correct. I don't know why the image is not showing. Let me run this. That is not at all how mine looks. Let me stop this. Let's see. Oh, we have to put this in a column. Oh, okay. So we go column. And then we got a row. Okay, so there's two buttons in this row. I see. Let me type this out. On click. Why is that not? Oh, that's not there. Never mind. And we got the button. Okay, those buttons go inside here. Now let me run it. Well, it shows up correctly over here, but not not there. I wonder why. Does this show how it's supposed to look? Yeah, it shows it taking up the whole space. Alright, now what if I ran it? Fill max width. Will this also take up its max width? Or maybe I put, what does this do? No, that didn't work. How about actually, let me keep trying the row. Maybe there's like arrangement. I don't know, maybe I'll just add it right on the button. How about modifier, weight, I'll do 1, F, and add that to the other button. Now let's run it. There we go, that's better. Alright, enough of this. Let me close that. Next one. Alright, Compose promotes reusability of composables, such as small chunks that can be enough for some custom layouts by combining built-in composables such as column, row, or box. However, you might need to build something unique to your app that requires measuring and laying out children manually. For that, you can use layout composable. In fact, all higher level layouts like column and row are built with this. Note, in the view system, creating a custom layout required extending view group and implementing measure and layout functions. In Compose, you simply write a function using the layout composable. Before diving into how to create custom layouts, we need to know more about the principles of layouts in Compose. Alright, some composable functions emit a piece of UI when invoked that is added to a UI tree that will get rendered on the screen. Each emission or element has one parent and potentially many children. Also, it has a location within its parent, XY, and a size, width, and height. Elements are asked to measure themselves with constraints that should be satisfied. Constraints restrict the minimum and maximum width and height of an element. If an element has children elements, it may measure each of them to help determine its own size. Once an element reports its own size, it has an opportunity to place its child elements relative to itself. This will be further explained when creating the custom layout. Compose UI does not permit multi-pass measurement. This means that a layout element may not measure any of its children more than once in order to try different measurement configurations. Single pass measurement is good for performance, allowing Compose to handle efficiently deep UI trees. If a layout element measured its child twice and the child measured one of its children twice and so on, a single attempt to lay out a whole UI would have to do a lot of work, making it hard to keep your app performing well. However, There are times when you really need additional information on top of what a single child measurement would tell you. For these cases, there are ways of doing this. We'll talk about them later. Using the layout modifier. Use the layout modifier to manually control how to measure and position an element. Usually the common structure of a custom layout modifier is as follows: function, modifier, custom layout modifier, modifier layout, okay. Measurable, constraints. Alright. When using the layout modifier, you get two lambda parameters: measurable, children to be measured and placed, constraints, minimum and maximum for the width and height of the child. Let's say you want to display a text on the screen and control the distance from the top to the baseline of the first line of text. In order to do that, you'd need to manually place a composable on the screen using the layout modifier. See the desired behavior in the next picture, where the distance from the top to the first baseline is 24 dp. Let's create a first baseline to top modifier first. Alright, I took a little break. Let's pick up where we left off. Alright, so we need to, let's create a first baseline to top modifier first. Okay. Stop this. Nope. Okay. Alright, so let me get a little more space here. I'll go right here. Actually, I don't think that's a compose. Let's create. Where does it say to create this? Let's see. I'm just gonna copy this. Let's see where to put this. I put it here. Alright, the first thing to do is measure the composable. As we mentioned in the Principles of Layout and Compose section, you can only measure your children once. Measure the composable by calling measurable.measure constraints. When calling measure constraints, you can pass in the given constraints of the composable available in the constraints lambda parameter, or create your own. The result of a measure call on a measurable is a placeable that can be positioned by calling place relative xy, as we will do later. For this use case, don't constrain measurement further. Just use the given constraints. Okay, that's what we have. Now that the composable has been measured, you need to calculate its size and specify it by calling the layout with height method, which also accepts a lambda used for placing the content. In this case, the width of our composable will be the width of the measured composable, and the height will be the composable's height with the desired top to baseline height minus the first baseline. Oh man. Okay. I'm just gonna let's see, place all that right here. I'm gonna copy that, put that there, get rid of that ellipses. Okay, check the composable has a first baseline, check, and then placeable Placeable is the result of measure on a measurable. Okay. First baseline equals placeable first baseline. Okay, height of the composable with padding minus first baseline. Placeable y. First baseline to top, round to pixels, minus first baseline. Height equals placeable height plus placeable y. And then layout, placeable width, height. Okay. Now you can position the composable on the screen by calling placeable.placeRelative xy. If you don't call placeRelative, the composable won't be visible. PlaceRelative automatically adjusts the position of the placeable based on the current layout direction. Warning: when creating a custom layout or layout modifier, Android Studio will give a warning until the layout function is called. Okay, that's good. In this case, Y position of the text corresponds to the top padding minus the position of the first baseline. Okay. Placeable, place relative. Okay. To verify this works as expected, you can use this modifier on a text as you saw in the picture above. Okay, let's add these preview functions. And we got to add the right theme. It's Compose Layouts theme. Not this one. And let's do a build and refresh. Okay, so we can see the differences here. All right, yeah, you can see the difference in padding or spacing. All right, good, good. Using the layout composable, instead of controlling how a single composable gets measured and laid out on screen, you might have the same necessity for a group of composables. For that, you can use layout composable to manually control how to measure and position the layout's children. Usually the common structure of a composable that uses layout is as follows. Okay. Okay. The minimum required parameters for a custom layout are modifier and content. These parameters are then passed to layout. In the trailing lambda of layout of type measure policy, you get the same lambda parameters as you get with the layout modifier. To show layout in action, let's start implementing a very basic column and layout to understand the API. Later, we will build something more complex to showcase flexibility of the layout composable. Implementing a basic column. Our custom implementation of column lays out items vertically. Also, for simplicity, our layout occupies as much space as it can in its parent. Create a new composable called my own column and add the common structure of a layout composable. All right, grab this composable. I'm going to put it right there. My own column, import this. Okay. As before, the first thing to do is measure our children. That can only be measured once. Similarly to how the layout modifier works. In the measurables lambda parameter, you get all the content that you can measure by calling measurable.measure, passing in the constraints. For this use case, you won't constrain our child views further. When measuring the children, you should also keep track of the width and maximum height of each row to be able to place them correctly on the screen later. Okay, so this goes in inside right there. Oh, I see. No, that is correct. What is the problem? Create function layout? Is that not a... Why does it not like that? There's the function. I'm going to grab the whole thing. Oh, I see. So, okay. Now that you've measured, I think the reason it's throwing an error is because it hasn't, the code, we haven't gotten to the Codelab part where we actually call layout. Okay. Okay. Now that you have the list of measured children in our logic, before positioning them on screen, you need to calculate the size of our version of column. As you're making it as big as its parent, the size of it is the constraints passed in by the parent. Specify the size of your own column by calling the layout with height method, which also gives you the lambda used for placing the children. Yeah, okay. Lastly, we position our children on the screen by calling placeable.placeRelative xy. In order to place the children vertically, we keep track of the y coordinate we have placed children up to. The final code of my column looks like, let's see, val placeables, got that. Var position, y position, we need to keep track of that. Layout, I'm going to grab this whole thing. Okay, let's see, layout, constraints max width, max height, and then placeables for each placeable, place relative, x equals 0, y equals y position, and then y position plus add to it placeable dot height. Okay, I see. So these are each of the children. For each of them, place it at the 0 x-axis, and then the current y-axis, it'll start with 0, and then increment the y-axis with the height. All right, let's see what that looks like. Are we or not calling that anywhere? My own column in action. Let's see my own column on the screen by using it in the body content composable. Replace the contents inside body content with, all right, let's add this to body content. Let's see body content, where's that at? Are we previewing body content anywhere? No. I'll add it here. It's going to be this one. My own column places items vertically. We've done it by hand. Cool. Next. Complex custom layout. Once the basics of layout are covered, let's create a more complex example to showcase the flexibility of the API. We'll build a custom material study owl staggered grid that you can see in the middle of the following picture. Okay, that's a very nice looking layout. Owl staggered grid lays out items vertically, filled out a column at a given time, at a time given a n number of rows, doing this with a row of columns. I see. Alright, doing this with a row of columns is not possible since you wouldn't get the staggering of the layout. Having a column of rows could be possible if you prepare the data so that it displays vertically. Okay. However, the custom layout also gives you the opportunity to constrain the height of all items in the staggered grid. So to have more control over the layout and learn how to create a custom one, we'll measure and position the children on our own. If we wanted to make the grid reusable on different orientations, we could take as a parameter the number of rows we want to have on the screen. Since that information should come when the layout is invoked, we pass it as a parameter. All right, let's grab the staggered grid. Okay. As before, the first thing to do is measure our children. Remember, you can only measure your children once. For our use case, we won't constrain our child views further. When measuring our children, we should also keep track of what's the width and max height of each row. Okay. Let me paste this in here and I'll read it. Oh man, what happened? Okay. Okay. Let me read this. Actually, I'll read it in here. It looks a little nicer. All right. Let's see. Keep track of the width of each row. Row widths. That's an integer array of rows. Okay. Equals integer array. Okay. Row heights. Integer array of rows. Okay. Don't constrain child views further. Measure them with given constraints. List of measured children. Okay. Map index measurable. Okay, I remember this from before. Placeable, measurable, dot measure constraints. Okay, and that's iterating over the measurables as well. Okay, track the width and max height of each row. Row equals index modulo rows. Okay, rows width, row of the row. Okay, row widths of the row. Oh, so this is like every other? Because that's going to be basically, yeah, I think it's like doing every other, because that's gonna basically, it's gonna be even or odd, and when it's even, it does one thing odd and then adds it to it. Okay. Row heights equals math max row heights of the row. Man, this is a little confusing. So, okay, placeable dot height. Okay. So you're setting the row widths and the row height. I see. Okay. Oh, I see. Okay, so that's just, okay, that's just an integer. Oh, that makes sense now. All right, so for each of those, oh, I see. Placeable dot width, row heights, math dot max, row heights of that one, placeable height. Okay, placeable. Okay. Now that we have now that we have the list of measured children in our logic, before positioning them on screen, we need to calculate the size of our grid. Full width and height. Okay. Also, since we already know the maximum height of each row, we can calculate where we'll position the elements for each row in the Y position. We save the Y positions in the row Y variable. Okay. See, I don't know, where does this go? Does this go inside here or outside? I'm just gonna wait till the end to copy it, because I don't know if that goes inside this function or outside of it. Lastly, we position our children on the screen by calling placeable place relative xy. In our use case, we also keep track of the x coordinate for each row and the row x variable. I'm not going to copy anymore because I don't know where everything's going. Using the custom staggered grid in an example. Now that we have our custom grid layout that knows how to measure and position children, let's use it in our app to simulate owls, chips in the grid. We can easily create a composable that does something similar. Okay, so this is going to be like the list item, that chip. Okay, well, I'm just going to copy that. And then change the theme. Import that. Okay. Create a list of items. There's the topics. Okay. Body content, we already have that. And then staggered grid. Is that what this one is? Staggered grid. It doesn't show the final staggered grid though, does it? Oh man, this Codelab kind of sucks. Alright, I guess we have to figure that out. I assume they're after. I'm going to assume... Actually, I don't know. It's not really clear. Let's see. Okay, there's the layout. I think it's after, yeah. Well, we'll try it after. If that doesn't work, we'll put it inside. Okay. I don't really understand that code, but we're going to try it anyways. Alright, this is our body content. Are we calling body content anywhere? Yes, right there. And I'm just going to run this. What's being set here, though? Layouts, Codelab, what's here? Inner padding. I want to actually see this on a device. Body content. Let's run it on a device. Okay, are they supposed to be scrollable? Okay, here's body content. Let me update it with this. Alright, the preview. As depending on the number of rows, our topics can go off screen. We can make our body content scrollable by just wrapping the staggered grid in a scrollable row and passing the modifier to it instead of staggered grid. Okay. Ah, shoot. Alright, there we go. If you use the interactive button, there's an interactive button on this. It's probably on design. I do not see it. Or run the app on a device. I'm just gonna run it on a device. Run button. You'll see how you can now scroll horizontally. Very cool. Under the hood. Now that we know the basics of modifiers, how to create custom composables and measure and position children manually, we'll better understand how modifiers work under the hood. As a recap, modifiers allow you to customize the behavior of a composable. You can combine multiple modifiers by chaining them together. There are multiple types of modifiers, but in this section we'll focus on layout modifiers since they can change the way a UI component is measured and laid out. Composables are responsible for their own content, and that content may not be inspected or manipulated by a parent unless the composable's author exposes an explicit API to do so. Similarly, modifiers of a composable decorate what they modify in the same opaque way. Modifiers are encapsulated. Analyzing a modifier. Since modifier and layout modifier are public interfaces, you can create your own modifiers. As we used modifier.padding before, let's analyze its implementation to understand modifiers better. Padding is a function that is backed up by a class that implements layout modifier interface, and it's going to override measure method. Padding modifier is a regular class that implements equals, so the modifier can be compared across recompositions. As an example, here's the source code of how padding modifies the size and constraints of the element it is applied on. Of the element is applied on. Okay. Let's see. Stable, fun modifier padding. All DP equals this, then padding modifier start. Okay. Implementation detail, private class, padding modifier, val start, DP. Okay, sets them all to 0, right to left aware, boolean. Inherits from layout modifier. Okay. Override, measure scope, measure. It returns a measure result. Horizontal start round. Okay, so the start pixels plus end pixels, vertical top. Okay, same thing. Placeable measure constraints offset minus horizontal minus vertical. Okay. Width constraints constrained width, placeable width plus horizontal. Placeable width, okay. Height equals constraints constrain height, placeable height plus vertical, makes sense. Return the layout with height. Oh, I see. And then if it's right to left aware. Okay, the new width of the element will be the width of the child plus the start and end padding values coerced to the element's width constraints. The height will be the height of the child plus the top and bottom padding values coerced to the element's height constraints. Order matters. As you saw in the first section, order matters when chaining modifiers as they're applied to the composable they modify from earlier to later, meaning that the measurement and layout of the modifiers on the left will affect the modifier on the right. The final size of the composable depends on all modifiers passed as a parameter. First, modifiers will update the constraints from left to right, and then they return back the size from right to left. Let's see this better with an example. Let's see, body content takes a modifier. It's a row. Modifier equals the modifier passed in, background size, padding, horizontal scroll. Remember, scroll state, staggered grid. Okay, the modifiers applied in this way produce this preview. First, we change the background to see how modifiers affect the UI. Then we restrict the size to 200. Okay, width and height. And lastly, we apply padding to add some space between the text and surroundings. Because the constraints are propagated through the chain from left to right, the constraints with which the content of the row to be measured are 200 minus 16, okay, for both minimum and maximum width and height. This means that the size of the staggered grid will be exactly 168 by 168. Therefore, the final size of the scrollable row after a modify size chain is run from right to left will be 200 by 200. If we change the order of modifiers to apply first the padding and then the size, we get a different UI. In this case, the constraints that the scrollable row and padding had originally will be coerced to the size constraints to measure the children. Therefore, the staggered grid will be constrained to 200 dp for both minimum and maximum width and height. The staggered grid size is 200 by 200 and the size is modified from right to left. Padding modifier will increment the size 200, 1616 by 200, 1616. Okay. That will be the final size of the row as well. I see. And that's when we do it padding first. Okay, that makes sense. Alright. Layout direction. You can change the layout direction of composable using layout direction ambient. If you're placing composables manually on the screen, the layout direction is part of the layout scope of the layout modifier or layout composable. When using layout direction, place composables using place as. Unlike the place relative method, it won't actually mirror the position right to left context. Okay. Full code for this section. Does it have everything or just the last stuff? Okay, it doesn't have everything, just the last stuff. Alright, how much time's left? What do they say? 17 minutes. Here we go. Constraint layout can help you place composables relative to others on the screen and is an alternative to using multiple rows, columns, and boxes. Constraint layout is useful when implementing large layouts with more complicated alignment requirements. In the view system, constraint layout was a recommended way to create large and complex layouts, as the flat view hierarchy was better for performance. However, this is not a concern in Compose, which is able to efficiently handle deep layout hierarchies. You can find the Compose constraint layout dependency in your build.gradle. Is it already there? If not, let's add it. Constraint layout. I don't think it's here. Let me add it. Constraint layout in Compose works with a DSL. References are created using create refs or create ref, and each composable in constraint layout needs to have a reference associated. Constraints are provided using ConstraintAs modifier, which takes the reference as a parameter and lets you specify its constraints in the body lambda. Constraints are specified using link2 or other helpful methods. Parent is an existing reference that can be used to specify constraints towards the constraint layout composable itself. Let's start with a simple example. Okay, I'm just going to copy this whole thing. Okay, had to get the right import, and it has to be a compose import, not the import from the constraint layout from the classic view system. All right, let's build and refresh. The constraints, this constrains the top of the button to the parent with a margin of 16 dp and a text to the bottom of the button, also with a margin of 16 dp. Let's look at it. Where'd it go? Okay, constraint layout, button, text, create refs. It returns constraint layout scope, constraint layout references. Jeez. This is, I don't know, this whole thing kind of reminds me of like the first time learning how to do layout. Like there's some useful stuff that can be carried over into doing from like doing it with XML, but it's basically like relearning something completely different. Okay, if we wanted to center the text horizontally, we can use the center horizontally to function that sets both the start and end of the text and edges to the parent. Okay, this is constraint layout content. Is this being added? Yeah, this is being added. Okay. This is in constraint layout. Oh, I already added this. Oh, wait, no, I didn't. Whatever, just add another one, I guess. I think. Oh, it's supposed to be the same one. Okay. Okay. Constraint layout composable. Okay. All right. Helpers. DSL also supports creating guidelines, barriers, and chains. For example. All right. All right, so there's button, text. Now let's add another button. Where does it get button 1 from? Oh, I see. So we have to add, these are create refs. Gosh, this is really confusing. Honestly, I feel like I'm just copying and pasting. I don't really understand any of this. I kind of do, but not really. I'm just in case I copied things wrong, I'm just going to copy this whole function. Because I see that some things changed here. Alright, customizing dimensions. By default, the children of ConstraintLayout will be allowed to choose the size they need to wrap their content. For example, this means a text is able to go outside the screen bounds when the text is too long. Okay. So this is a completely new one, isn't this? Yeah, this is a completely new. Yeah. New function here. Oh, and I gotta grab the right theme because that's the wrong one. Okay, obviously you'd like the text to break in the available space. To achieve this, we can use the width barrier of the text. Alright, I'm just gonna grab the whole large. Where is it? Large. Let's see. Constraint layout compose. It's that one. With preview, okay. Available dimension behaviors are all of those. Also, certain dimensions can be coerced. Oh, okay. Constraint set. You gotta be careful when importing. Make sure you get the right one. Okay. Alright, last one, intrinsics. One of the rules of Compose is that you should only measure your children once. Measuring children twice throws a runtime exception. However, there are times when you need some information about your children before measuring them. Intrinsics let you query children before they're actually measured. To a composable, you can ask for its intrinsic width or intrinsic height. Intrinsics width gives, given this height, what's the minimum / maximum width you can paint your content properly? And then the vice versa, intrinsic height, given the width, what's the min-max height you can paint your content properly? For example, if you ask the minimum intrinsic height of a text with infinite width, it'll return height of the text as if the text was drawn on a single line. Intrinsics in action. Imagine that we want to create a composable that displays two texts on the screen separated by a divider like this. How can we do this? We can have a row with two texts inside that expands as much as they can and add a divider in the middle. We want the divider to be as tall as the tallest text and thin, 1 dp. Okay, let's add this code. Grab the right theme. All right, rebuild. If we preview this, we see that the divider expands the whole screen, and that's not what we want. This happens because a row measures each child individually, and the height of text cannot be used to constrain the divider. To constraint the divider? Okay. We want the divider to fill the available space with a given height. For that, we can use the height intrinsic min modifier. Height intrinsic size min sizes its children, being forced to be as tall as their minimum intrinsic height. As it's recursive, it'll query row and its children min intrinsic height. Applying that to our code, it'll work as expected. All right. I'm just going to recopy this function. Oh, no. That. With preview, hi there. Okay. Row's min intrinsic height will be the maximum min intrinsic height of its children, and divider's min intrinsic height is 0 as it doesn't occupy space if no constraints are given. Text's min intrinsic height will be that of the text given a specific width. Okay. Therefore, row's height constraint will be the max min intrinsic height of the text. Divider will then expand its height to the height constraint given by row. DIY. Whenever you are creating your own custom layout, you can modify how intrinsics are calculated with the intrinsic width height of the measure policy interface. However, the defaults should be enough most of the time. Also, you can modify intrinsics with modifiers overriding density of methods of the modifier, which also have a good default. Congratulations, you've successfully completed this Codelab. All right, my thoughts on this. It kind of sucks. It feels like you're throwing 98% of what you learned from XML and just throwing it in the trash. I mean, I've done custom views, worked with XML, frame, all of them, linear, coordinator, constraint, motion, layout, relative, and yeah, I mean, it seems like very little is able to be kind of passed over to this. I feel like it's better, but it's just like, it feels like you're starting all over. You're learning from square one all over again. So it kind of sucks, but it's, I don't know, maybe once I learn it, I'll think different of it. But for now, it seems incredibly complex, and this Codelab was not really, I don't know, I feel like a video explanation of this would be better so you can follow along. But anyways, that's my thoughts on this Codelab. I hope you enjoyed it more than I did, and thanks for watching.